Hello and welcome to test number 9, looking at how to answer maths questions in chemistry. There's 5 questions in this test that we're going to have a look at, and we're going to start off with a nice easy 1 marker. Okay, so again, lots of information in this question, but you don't need all of it. The first part is just to set the scene for it really. A student adds dilute sulfuric acid to dilute potassium hydroxide solution, and a neutralisation reaction takes place. The student records the temperature change for this reaction over 30 seconds. His results are shown in the table below. Calculate the percentage increase in temperature between 5 and 20 seconds. So I only really need these 2 sets of data. I only need 5 and 20. I don't need all the others. So first of all, I work out the difference. So 27.6 take away 25.8 equals 1.8. I then divide that by my original amount. 1.8 divided by 25.8 times 100 equals 6.976. Or if I round it to 2 decimal places, 6.98. Always look to see whether they want 2 decimal places. In this case, I've just rounded it up because that looks like it's probably going to be 98. So that's a nice little 1 marker. So onto this 2 marker then. So looking a little bit more detail. Nazira recorded the change in mass of reactants in an experiment. She repeated the experiment 4 times and calculated a mean. Her results are shown in the table. Calculate the mean of the results in the table, but again, make sure you pay attention to this. Give your answer to 3 significant figures. These are 2-mark questions. Calculating a mean is really easy. You add up your 4 results, divided by 4, and it comes to 2.4925. Always write that down because that is going to get you 1 mark. However, the second mark comes from converting that into 3 significant figures. Well, I've got 25 there, which is too low, so it's just going to be 2.49, and that's your second mark just from the conversion. Okay, question 3. So this one, the number of particles in 1 mole of an element or compound is known as Avogadro's constant. Excuse me. Avogadro's constant is 6.02 times 10 to the 23. Excuse me. Excuse me. Calculate the number of particles in 3.5 moles of a compound. Now that is quite a big number, obviously. So 6.02 times 10 to the 23, but I've got 3.5 moles of it. So I'll multiply that by Avogadro's number, and I get 2.107 times 10 to the 24. But just to round it up, I've got 2.1 times 10 to the 24, because it actually says here, give your answer in standard form. Now that was only a 1-mark question, so if you didn't do that, you would have lost out on a mark. Okay, question 4. Another molar question. We like looking at these. So a student uses 0.012 moles of hydrochloric acid to neutralise 25 centimetres cubed of sodium hydroxide solution in a titration. The concentration of the hydrochloric acid he uses is 0.25 moles per decimetre cubed. Use the formula to calculate the volume of acid required to neutralise. So again, I've put my calculation into a triangle. There's my divide line. Moles goes at the top. The other 2, concentration and volume, at the bottom. For this calculation, I need the volume. So I'll put my finger over volume, and then it's moles divided by concentration. So my moles is 0.012, and I've taken that information from there. My concentration is 0.25 because it's told me that there. Simple, straightforward divide, and the answer is 0.048. The reason you get 2 marks for this one is because 1, you had to actually work out your calculation and what it would be, and then you had to put your numbers in to work out what you'd get. Okay. Right, the last question then is another graph question. Now, when I first started to answer this question, I actually changed my mind on how I'd tackle it. So I'm just going to show you what I did. The graph below shows the amount of reactant remaining in a reaction over 150 seconds. Calculate the rate of reaction at 60 seconds. Include units for the rate in your answer. So there's my 60 seconds, but this time if you look, the curve is inverted. That doesn't mean I still need to have a tangent. So if you remember from previous videos, I always say a tangent is like 90 degrees to the line, And then I just make sure that this gap and this gap are about equal, so I know my line's in the right place. When I started to look at the values that I was going to use to work out my change in y divided by my change in x, I just thought to myself, okay, I want to make this as easy as possible. So if I do change in y divided by change in x, and I go from from 30 to 90, that's going to be 60 seconds. And then by using that and that value, I could work out the difference was 1.9. So it's 1.3. So it's 1.3 divided by 60 because that's my x value. That was my y value, and the answer was 0.021. Okay, so working out a rate of reaction is change in y divided by change in x. The reason I changed my mind is because I wanted to try and make it as easy as possible to try and read. So that's why I went from 30 to 90, because I could get this straightforward 60. And I look forward to seeing you for the next and last maths test, test 10. Thank you.